So meanwhile, most aquaculture-related reports and studies presented land change as mainly an economic opportunity. Uh, but making this causal connection between environmental or economic drivers and autonomous human responses needed more rigorous methodological intervention. And this was when also, it was in between COVID, and this was also when I decided to take a pause from our, regular practice and deep dive into a PhD to explore these land transitions and of aquaculture and understand the complex drivers of human behavior and their feedback implications for places that they inhabit. So in today's talk, though, I will focus more on the value of field-based interdisciplinary inquiry, given that the questions also emerged from the field for me, and also the use of mixed methods to unravel such complex social environmental system questions. And I will share some preliminary findings, given that the work is still in progress. I'm still at least a year and a half away from completing my dissertation, but I will focus more on the potential implications of the findings for climate science and policy. So for those of you not too familiar with what aquaculture is, so aquaculture is the practice of farming fish. Now, this can be done on land or in marine environments. What you're seeing on the screen is a typical image of a land-based aquaculture pond dug out of what was previously a rice field. Now, using such ponds, people are practicing brackish water aquaculture by pulling seawater into the land to grow predominantly a particular shrimp variety in at least in coastal India. They're also growing fish, but much less. There's a particular variety of shrimp called Pinus vietnami, which is also in short in those regions called vietnami. But you may know it as white leg shrimp that is most commonly seen at your fishmongers. So that's kind of like a monoculture that's happening across the coast right now. To give you also a sense of this transition in spatial terms, this is an image of Ersama, which is a block in Jagatsinghpur district in Orissa. This is an image from 5 years after it was badly affected by the 99 super cyclone and storm surge, when seawater intruded over 25 kilometers into the land. So what you see here is mainly agricultural fields interspersed with some sort of perennial water channels that have been used for irrigation for several decades before that. And this is an image about 10 years into post the last image, and what you see in this area is completely transformed into brackish water aquaculture. So what each of these little squares that you're seeing is an aquaculture pond. So it's transformed significantly. And this story is not unique to Ersama. Now, this is an image of Machilipatnam. And what you're seeing, just for a sense of scale, so the point where I am, this little point, this is just a screenshot of a Google Map image. And this one pond is about 3 acres right next to me. As we zoom out, we see that this entire area is aquaculture. We zoom out further, and almost 90% of the area here as well, which is not, let's say, not the road network and some habitations in between. Most of that area is also aquaculture. And then further, when you zoom out even further, all of this area, Gangavaram, Bhimavaram, these are known for their aquaculture practice, and much of that area is now aquaculture. So this just kind of gives us a sense of how big and massive it is, and either side of the roads when you go around in these areas is predominantly aquaculture. Some studies have estimated that by 2019, over 3,200 square kilometers, or about 30% of the coastal areas, were under aquaculture, and about 28 million people, or about 3 crore people, were directly drawing their livelihood from it. Most of whom are small-scale farmers with about 1 to 2 acres of land holding. And if we also include people who are involved in the allied services related to aquaculture, it goes to about 5 crore people. And this story is much further beyond India. So globally, if we see, half of the fish that the world is eating right now comes from aquaculture. And this is this is the fastest growing food production sector, meeting the increasing food demands, especially with capture fisheries that stagnated around the 1990s. You see that there's a stagnation. It's both because of policy measures, but also because of just general decrease in wild fish available. So much of the growing demand is now being met by aquaculture, and in that there are two kinds. One is the light pink part that you're seeing, that's marine-based aquaculture, where fish is farmed in the sea itself, and then this the darker pink part is where fish is grown inland on land, and that is the part that's growing significantly. And there are also projections and studies that suggest that aquaculture will continue to depend more on land than sea. So it becomes important for us to focus on these land-based aquaculture, inland aquaculture, especially because this particular kind of land change is irreversible. It's mostly irreversible given the resources available or time spans important to society. The once the land is converted to these ponds, it's difficult to go back to the previous users. Meanwhile, as I said before, I mean, aquaculture is pitched as a big economic opportunity. In 2010, there was a UN report that suggested that aquaculture had the potential to sort of feed the large sort of populations, growing populations, and also provide a major source of protein, and in that sense cut poverty and combat food insecurity. This in a way also promoted a lot of the governments to start sort of supporting and subsidizing aquaculture, especially countries like Vietnam and Thailand. They started providing subsidies to people to promote aquaculture in their regions. It also diversified aquaculture systems across. So that also led to a rapid expansion of aquaculture, especially in Southeast Asia and also in South Asia. So since then there are records of regional growth. And if you see overall, we see that even though this is an global economic opportunity, we see that there is a certain concentration of this particular land transition that's happening in countries like India, China, and Southeast Asia. And the question is that there's a certain lack of inquiry as to why these regions are the ones that are converting and not others. And that's not just the question at that global scale, but even within a country like India. So India is the second largest producer of aquaculture. And when we see the concentration of aquaculture even within India, this is a study by Prasad et al. In 2019, and they identified regions where aquaculture is concentrated. And we see that even though there are, in many states, there are state subsidies for aquaculture, there's also this argument many present that, because rice had become just 1 rupees because of, subsidized rice provisions by the state, so people don't have an incentive to grow rice anymore. But the question is that, that 1 rupee rice is 1 rupee rice across all the districts. Why is it that only some districts are converting and not the others? There could be many arguments, of course. But some qualitative studies tend to suggest that there are connections with past storm surges where sea water intruded these areas, but also increasing salinity, which is particularly the case in Vietnam, where people have been seen to convert from rice to aquaculture. One of these studies, which is Vasudha Chotrai's study, is also part of, it also came out of the work we did together in coastal Orissa as part of this project called Recovery with Dignity. But most of these arguments are not tested robustly. These are still qualitative studies, and this connection still needs to be made. In order to do that, just for a quick view, what I did was I mapped all the historical storm surges in coastal India from 1880 to 2015 using data from SurgeStat, which is a documentation of all storm surges across the world. And what we see is there's some uncanny at least visually, we can see that there's an uncanny relationship between where the concentration of past aquaculture, past storm surges is also where aquaculture seems to be quite quite strongly concentrated. But to also test for salinity, we've also been mapping salinity across India, which is much more coarser and diverse. So, testing that with better methodological processes is important. But so what? But so what if people are converting to aquaculture? So that is the main question here, that, there are studies, for instance, that have documented the environmental burden of aquaculture on, let's say, groundwater or soil, or even the salinity impacts on human health. But given people have been facing rampant losses due to diseases or other market inconsistencies, there needs to be more rigorous record of the varying impacts especially for different people. There are also sustainable aquaculture policies that are aimed at addressing environmental burden or reducing the use of antibiotics even, but not so much on the livelihood and well-being dimensions of people and places. There are organizations like ICSF who've been also arguing that the impacts on people and places is understudied. So this kind of background brought me to these three main questions to pursue through my research. The question of where in India is aquaculture land transformation unfolding and why. That's more at the sort of national level. The second question was more at a household level as to why are people deciding to shift from rice to aquaculture. And the third was, what are the consequences of this land transformation for people and places? Again, more at a sort of, locally neighborhood or village or district level. So for this, I have used a conceptual framework. I draw on theories from land system science, climate change adaptation, and development studies to devise a conceptual framework. This framework helps me connect these cross-scalar drivers, decision-making processes at household level, and the consequences of these decisions for people and places. I broadly contend that households make livelihood decisions in the complex context of development pressures, as well as a means to deal with, of course, and I also like to give a shout out to Chandni here, because this the framework for household level decisions right here has been, she has done a fair bit of work on that herself. So this is just kind of building on top of the work that she and others have done. So what I contend is that, households make these livelihood decisions in these complex context of development pressures, environmental stresses, which are long drawn processes like salinity, and also environmental shocks, which are sudden shocks like storm surges. But these conditions moderate the social and the socioeconomic and environmental conditions that lead them to some critical moments where they transform lands in a way that they are effectively irreversible, especially in the resources available, or, like I said before, time frames useful for society. So thereby potentially introducing part dependencies, as you see here. So while people may be adapting, they can shift to pathways which are, which can lead them to continuous transformation and even climate resilient development pathways. But these path dependencies potentially could also decrease their resilience, reduce their adaptation options, and ultimately shift them to poverty traps. So the question is to understand what pathways are people taking and who's on what pathway, which people are on what pathways here. So to just summarize the questions and some of the hypotheses that I started this research with, as I said, the first question was to do with patterns, to understand what is the association of environmental shocks and stresses with human-led land changes, especially given that there are all these other drivers, other economic and social drivers. What is the association of these environmental impacts on these? And what I hypothesize is that aquaculture is concentrating in areas that are structurally poor, with low agricultural productivity, with a history of climatic shocks and stresses, suggesting that patterns of future growth with climate change are going to see similar shifts and changes going forward, having implications for future transformations and pathways for different types of places. In terms of the second question, which is what are the social and environmental conditions that are influencing land change decisions at a household level, I argue that household asset conditions, especially their land ownership and also their access to water resources, moderate their adaptive capacities, their choices, and ultimately their adaptive behavior, with some suggestive sort of, aspects about what are those tipping points at which people are making these transitions or these decisions to convert, even knowing that these changes may be irreversible. And ultimately, so what are the consequences, and both the social and environmental consequences? And I argue with this that land changes to aquaculture are, of course, accelerating and locking in salinity, and are associated with more negative outcomes for women and landless labor, especially given that they were able to work more in labor-intensive, processes like rice cultivation, whereas aquaculture being less labor-intensive has led to fewer employment opportunities for many of the landless and women, and also smallholder farmers are facing more challenges and more losses because of lack of ability to diversify. So today I'll focus on the first two questions a lot more than the first and third question a lot more than the second one, which is on drivers at household level, because and I'll speak about it, that the data for that I'm drawing on, the survey data has just come in, like practically 2 weeks ago. So I'm still in the process of analyzing it, but I'll share some early sort of hypotheses from there as well. So this is the first question on where this transition is happening. There's some current theories that suggest that, of course, agricultural transitions are widely attributed to economic changes. And so there are economic, it is indisputable, it is accepted that there are economic arguments for these land transitions. But these economic transitions, what I'm arguing here, is also supported and informed or affected by ongoing environmental changes. And these environmental changes have in other contexts been seen, environmental shocks and stresses have been seen to affect land use trajectories for places, with having implications for their long-term development outcomes. And there's also literature that suggests that responses, especially sort of adaptation responses to these environmental shocks and stresses, may be slow. They may be, so the shock may happen. The shock may have happened in 1999, but the actions will and can take much longer, and people may take an action of, especially a land change type of action, may take 10, 15, 20 years from then. They may be incremental. People may take small steps before, and then the big change may happen. They may be small scale. They may be spatially discontinuous. And therefore, because of these factors, making a causal link between these environmental shocks and stresses with the resulting land changes has remained difficult. So the idea here with this research is to build that causal link and do it over time. To do this, I've developed a database which consists of villages across the coastal belt of India, which is about 83,000 villages. I've taken the period of study from 1990 to 2020, which is also, if you recall that first graph I showed you, the pink and blue graph, the aquaculture has actually globally increased or from 1990 onwards. So this period of study kind of aligns with that, the global processes. And I've broken that into sort of seven time periods of 5 years time steps to see how that has evolved and how these different events have interspersed and how over time that has been making a change. I'm using remote sensing and some machine learning frameworks to develop this. So I've used Landsat 5 and 8 images for this, and I've conducted a supervised land use land cover classification to identify the lands that have aquaculture over these different time periods. So each of these is, as I said, the 7 time period timestamps, and what I'm achieving is an overall accuracy of about 86% in the Landsat 8 images and about 78% in Landsat 5, which is fairly decent for this work, although I'm trying to make it better with more machine learning processes here. Then I've also so far I've been using already existing salinity indices to kind of track how salinity has been changing in these areas. The issue here has been that most of the salinity indices have been developed in the context of drought or arid regions, and this is a more tropical environment, and so I'm trying to develop and calibrate the existing indices for this area. And I'll share shortly why the existing indices don't give the right sort of correct insight, and so this developing new index is important, which is currently in process. Also, I have modeled some of the storm surge experiences using the SurgeDat database I mentioned before, and using the digital elevation model and having the information on the depth of impact and the width of impact from these points. I've modeled which of these villages have been affected in the past, and I'm triangulating that and that modeling with some of the reports by the state governments, and also UNDP has some good resources for that as well. So I'm triangulating the villages that have been affected to include in the model. And then I'm controlling for existing land uses. For example, land uses like urban areas or built up areas are less likely to get converted to aquaculture versus, let's say, if it's a mangrove, it is more likely to be converted. I'm also controlling for other socioeconomic variables at the village level, taking that from the village directories. So not going into too much detail of what this looks like, what the equation really is, but very simply, I'm trying to build a causal, I'm drawing from a causal inference methodology, which is matching like-to-like villages and only seeing how the transitions are happening. And within that, I am taking the area under aquaculture in each of these villages at a particular time as my dependent variable, and trying to see the association of that with whether that place has been affected by storm surge or not, and the different levels of salinity over time. And then, of course, there are different relationships and interactions between salinity and storm surge also that I have been capturing in this. Broadly, I'm presenting now a pilot study that I've already kind of completed, but I'll model that for the rest of the post as well. I started with 4 districts, 2 of which have had a history of a storm surge and 2 of which do not have that, across Orissa, Andhra, and Tamil Nadu. What I'm finding with this analysis and the framework I presented was that very evidently the places that have been flooded in the past have a higher and steeper change. I mean, they have more aquaculture, and the pace at which these places are converting is also much faster than places that have not been that are not flooded. When I break this further and these places by both salinity and flooding, what I'm seeing though here is that places which have been flooded but have lower salinity by the existing indices that are available, have lower salinity, seem to be accumulating this change faster. Now, the problem with the salinity aspect here that I mentioned before is that salinity may actually here be an indicator or a more of an indicator, not so much of salinity, but wetness, because uh, this index, which is soil salinity and sodicity index, for those of you interested, is have been developed for drought-prone areas or arid regions, and it also is used as a proxy for drought. And so the higher the index is, the better the places may be. So this sort of, using a better index might give us a better insight on whether salinity has an impact or not. But at this point, the data seems to show that places with what we can find from, at least even if this relatively undeveloped index, is that flooded but wetter places have higher likelihood of shifting to aquaculture. So wetter places meaning places that have more likelihood of having access to water, because I've already masked aquaculture ponds themselves. So it is the land and the wetness of that and the access to water that is what is getting shown in this model. When I convert the same lines into a map, just for better understanding, what I'm finding is that flooded but drier saline areas. So if we see the purple areas here, which is where more aquaculture is, also seems to be aligned with perennial water bodies. So these are flooded, but so to say low salinity, but wetter areas. And then there are these light blue areas which have been flooded, but are drier regions, seem to have less coping capacity to even shift. These places, even though they may be facing similar challenges as these wetter areas, but they are not being able to convert to even aquaculture. So they seem to have lesser coping capacities to convert to even this land use, which brings us to the second part of the question as to what are these household level dynamics and their resources which are affecting these decisions at a household level. So the current theories suggest and are very clear on this, that adaptive behavior is differential. It is moderated by different adaptive capacities and also institutional conditions and the access to different institutional support systems. But these adaptive capacities are also further moderated by asset conditions, what kind of land ownership they have, what kind of access to water and other resources they have, and which is what we need to kind of test here. What are these asset conditions that are leading to different behavior by different individuals? There's also a big literature also on social tipping points at which people are making these shifts to and shifting themselves into these new regimes. But the question here is whether people are shifting, seeing this as an opportunity, that this is something that will make their situations better than what it had before, or is it because they have lack of alternatives? Is it because that the things that they are currently aware of doing, which is growing rice, is not an option anymore. And so they feel that their adaptation choices are limiting or narrowing, and that's why they're shifting to this land change. Now, so to do this, I developed a survey instrument at a household level. And conducted this survey across 6 districts, 2 districts each in Orissa, Andhra, and Tamil Nadu. In each of the states, one district is where there has been a history of a storm surge in the past, and one where there hasn't been a history of storm surge. In Tamil Nadu, this is a slightly counter case where we've taken a place like Nagapattinam, which is not a storm surge situation, but it was the situation where tsunami affected. So the water intruded the area not because of a storm surge, but because of a tsunami, which in a way kind of models an absolute random, it randomizes the situation, because one could argue that, places that are being affected by storm surges have something in common. Let's say they are all low-lying areas, and that's why they are conducive for aquaculture and also attract storm surges, for instance. So in Tamil Nadu, we've taken a slightly different approach to randomize it and to include a place which is not storm surge, but tsunami affecting. The objectives of the survey were to mainly to understand things that are otherwise not possible to gather from other, let's say, remote sensing based methods or other secondary data. And this is to understand the kind of autonomy households are experiencing, whether they are making these decisions at a household level or whether they're influenced by other factors like, village level decisions or district level, or whether they're influenced by policy dynamics, etc. The second is also to understand their livelihood asset conditions before and after the storm, but also before and after the aquaculture practice itself. To also understand the motivations behind these changes, especially the enablers and barriers in these process of shifting, which would give us a sense of what we can expect the future changes to look like, what these areas, what kinds of people are likely to shift or not shift, and whether policy mechanisms can actually help those who feel that there are barriers and if they would like to shift, and what is it that can be done for them. And then the fourth, fifth, and sixth questions are more about the outcomes, where outcomes for households and their perceptions of what their actions are doing, what impacts do they have, what impacts does that have for their neighbors, but also for the next generation, and also to understand their perception of permanence within this, whether they have tried to go back to growing rice, and if yes, what challenges have they faced, and if not, do they feel that they could, and given that understanding, whether that influence their decision making or not. And then, of course, having converted, what are their perceptions for these choices going forward, especially given the changing climatic conditions. So this survey is to do that. And the survey is already completed as of 2 weeks ago, and I'm still in the process of cleaning the data. We've done this in Jagatsinghpur district in Orissa, Ganjam, Jagatsinghpur and Ganjam, both of them in Orissa, Machilipatnam and Nellore in Andhra Pradesh, and Nagapattinam and Tiruvarur in Tamil Nadu. We've collected about 1,250 household surveys, and have also conducted focus group discussions with groups of women, groups of landless labor, also groups of aquaculture collectives and unions across all these districts, to give us a sense of the motivations. Now, even though I don't have the results for this, but what I expect to find is that, or at least that's the hypothesis, is that access to economic and natural resources, especially the size and type of landholding and their access to water, is associated with a higher likelihood of the shift, moderating household adaptive capacities for this particular change. Change from rice cultivation to aquaculture is associated with experiences of storm surges, which is also an indication of neighborhood effects. As I would explain a little bit later, that people are experiencing, once the neighbor changes, they also face further reduction in their rice cultivation, and that has also been leading neighbors to convert faster. And sometimes neighbors converting is also influencing them with better knowledge or more access to other resources or access to market, etc., which is also leading them to make this shift. So there are neighborhood effects that are quite evident that I hope to test with this data. And overall, more largely, there are also evolving market and infrastructure systems which are driving this initial demand, but also motivating more shifts in the future. This brings us to the last part of the study, which is about the consequences. What we know from existing literature is that agricultural land transitions, especially which are intensive agricultural practices, could lead to excessive exploitation of natural resources and could push systems and places into these narrow development trajectories, and which are technically called traps, which overall could reduce opportunities in the future for people who are engaged with that kind of transition. We are seeing this not just in coastal areas, but we're seeing intensive agricultural and irrigation practices in India in places like Punjab and Haryana as well, where excessive irrigation has also led to increasing salinity and has pushed people to convert and try aquaculture even in much interior places such as those, and non-coastal areas such as those. There are also, as you know, as I said before, there are so intersectionality not just affects the options available, but also outcomes for social groups that different kinds of people like women and landless labor in this context are likely to be affected differently, and that is something that needs to be understood, which is not yet documented very well in existing research. There are several studies that are which are talking about negative environmental outcomes of aquaculture, which is what is promoting a lot of sustainable aquaculture policies as well in different parts of the world, including some also being promoted in India. There's also research that is pointing towards land subsidence which has been experienced in parts of Vietnam, where they're arguing that this land subsidence is a relative sea level rise, which is effectively adding, greater, effectively like that is the new sea level rise projection. I mean, that could affect the future projections. But overall, there is less understanding of the social outcomes of aquaculture transitions. There's also a significant amount of research on, how responses and adaptive and adaptation choices could potentially be maladaptive, or on the other hand, could be transformative. And the point here is to understand who is it maladaptive for and why, and if it is indeed transformative, and if it is actually climate resilient and people have better choices with this, what can be done to sort of help and promote this this shift. So in terms of the socioeconomic outcomes, again is dependent on that survey, which I will not be able to share the findings of right now. But what I expect to find is that land changes to aquaculture are associated with some decreased employment outcomes for women and landless labor compared to men and those who own land. So smallholders are likely facing more challenges in this and are sort of losing out much more than large landholders, especially because there are the significant experience of diseases, like their shrimp are catching diseases and they're not able to take on that kind of loss for and then a lot of them are having to leave the lands fallow and move out of these lands, or many of them are even experiencing selling of their assets like land and moving out of these areas. So it's potentially also causing out migration from these regions. People are also possibly experiencing this irreversibility of land change. And because of high operational costs, are not able to continue practicing even after having converted and even after having invested big capital costs, which are required to dig the pond and to make it, tenable for practicing aquaculture. They are not able to continue because the operational costs are still pretty high, and which is also leading to this fallow, this phenomena of fallow aquaculture across. In terms of environmental outcomes, what I contend is that these land changes to aquaculture are both accelerating and locking in coastal salinity, which in some ways could point in the direction of that relative sea level rise, although in this case is not so much about subsidence, but the fact that sea water is being pulled in much more interior places than the existing projections suggest. So this may actually have a bigger environmental and outcome, but also has um, implications for climate science overall. So some motivations from the field for this part of, I'll just present some of the environmental implications from this land change. People have mentioned that, they shifted from rice because they faced, groundwater and soil becoming too saline after the storm surge. Some of them also mentioned that as their neighbors converted to aquaculture, their lands stopped growing rice. So there was, some of them also mentioned that the lands right adjacent to the aquaculture ponds were facing loss of productivity over time. And although there was lack of clarity on up to what distance are they facing this kind of direct impact, which needed to be tested. At the same time, the aquaculturalists have shared that they use saline canal water for aquaculture, but they also add lime to increase the pH level. So one of the motivations is to understand whether the increasing pH levels that are needed for aquaculture are actually also causing so pH, for those of you who are if you don't recall from school science, that pH is a level of acidity or basicity of solutions and even solids, but it's a level of acidity. And what we know from other sort of generic knowledge is that for growing plants, the usual pH level is between 4 to 6 or 4.5 to 6.5, whereas for growing for animals, especially for crustaceans, the spectrum is between 7 to 9. Now, this is a logarithmic scale, so even a difference between 6 to 7 is 10 times. So there's 10 times more alkalinity between 6 and 7. So what we are seeing is that there is no overlapping window between growing rice and growing prawns. So if the farmers are increasing pH to grow prawns, that is likely to make it more alkaline, the environment more alkaline, which will not support production of rice after a point. So the objective for this particular part of analysis was to assess whether the soil changes, soil salinity and pH changes can be attributed to aquaculture practice, given there is already a whole lot of other things going on. There's storm surge, there's already coastal salinity and other aspects of salinity. So to actually attribute these changes to the practice of aquaculture was the biggest challenge here. Then we know that so the hypothesis is that aquaculture is contributing to that increase, and there is a certain neighborhood effect. But the method to kind of assess this, so I set up with a sort of natural experiment with some field-based environmental data on soil and water. With soil and water testing and sampling. So the site that I selected was in Ersima, an Ersima block. So now that entire area was affected, was flooded by the 99 cyclone. And it also is fairly homogeneous in terms of their socioeconomic and environmental context. And within that, the only varying part in that larger region is that one of the areas has much more aquaculture practice, whereas in the other, there's much less aquaculture practice. Over this, I overlaid like two sampling spaces, one treatment grid, which is where aquaculture is being practiced, treatment being aquaculture, and the other grid where it's technically a control grid, even though there is a little bit of aquaculture here, but in my assessment, in my methodology of control for that later. Now here, using these two sampling frames, I took samples across each of these grids, and a big shout out to Teja for helping with the data collection plan, and also Jagdish for his regular advice and extending some of the lab resources to make this happen. Big shout out also to Deepti Nagappa, who's an IIHS UFP alumni, who assisted me with the data collection, and this was quite a task to do it across. So overall, this is about 10 kilometers by 10 kilometers each of the grids. So it's about 200 square kilometer area between the two regions. Again, not getting into too much of the details of the mathematics in it, but to just explain that if this is the point where the sample is taken, I have calculated the area under aquaculture in three different bands, three different distances from these points. The first being 120 meters, then 240 meters, and 360 meters, kind of equivalent to about 1 acre, 2 acre, 3 acre sort of margins around this point, to get a sense of how far is this how far does this effect remain. And I've used fixed effects from the distance from the sea, which means that I'm only comparing farthest grid to the farthest grids in the two treatment and control areas, and not and closest to the sea to the closest to the sea. So there's no cross comparison, so that there is likely to be variation from as we go away from the sea in terms of salinity. So what I find here very quickly is that, so the bigger the spot, the bigger the dot here means bigger salinity, the yellow ones, and the bigger the blue dot means it's higher pH. So what we see very clearly visually is that area which has more aquaculture also seems to have higher salinity, and the area with lesser aquaculture has both lower salinity and relatively less pH as well. But in terms of the distance from the points, what I'm also seeing very evidently is that the impact of both salinity and pH decays with the distance, but remains significant up to 3 acres, which is up to 360 meters. It remains significant. The salinity is highest if it's away from 52. Salinity increases by 52 microsiemens per centimeter, about 120 meters away, whereas it goes up to about 6 microsiemens away from from aquaculture. But pH, even though the value may seem small here, but again, as I said, it's a logarithmic scale of pH. So even a 0.012 difference actually means about it's 10 times more in terms of the actual level of alkalinity. So both salinity and pH can be attributed to presence of more aquaculture in these areas. So just to conclude, what this means, what the implications for this mean for science, and especially climate science, is that, so while, sea level rise projections at the moment are being done using biophysical measures. So for instance, they consider future, policy dimensions. They also consider what those would mean for different adaptations, what that would mean for also, changes in global warming in the future, and how that would affect sea level rise, and how the sea level rise is going to effectively cover coastal areas and other smaller islands, and how, sea level rise projections are made based on these sort of biophysical phenomena. What this does not really include is these kinds of human adaptation responses in the process, which are potentially actively, by actively pulling seawater inside, they're potentially accelerating and locking in this sea level rise. So what this means is that this human adaptation response also needs to be included in these sort of sea level rise projections, which effectively may be an underestimate at this point. The What we also need to understand more about is these land transitions could be pushing these places into irreversible sort of traps. That can lead to social environmental collapse, given that a lot of these lands are fallow, maybe potentially just tracing and tracking the fallowness of land can also give us a sense of the tipping point at which people will make a shift from agriculture to aquaculture, and then from aquaculture to fallow, and move to other uses or livelihoods like migration. And the third is also to ultimately think about long-term adaptation engagement with climate hotspots, because many of these social environmental needs and livelihood needs emerge over a longer period of time. So it requires a longer-term engagement with place-based processes. There are some very clear policy implications as well. There needs to be a reimagination of post-disaster recovery practices and institutional systems to engage long-term monitoring of places. As I said before, many of these issues emerge over much after recovery actors have left these areas. Sustainable aquaculture policies must also include holistic environmental as well as social impact assessments, and also include policies for people whose livelihoods are involved with these, and not just the environmental aspects. There's also a potential to look into coastal zone regulations to have appropriate land use planning to identify lands which are more suitable for this kind of conversion versus those which need to be protected for agriculture and ongoing, protecting the groundwater and soil conditions in those areas. And ultimately also presenting some sort of additional social safety nets for coastal communities, which are dependent on these both fragile aquaculture and agricultural systems, and people who are already converted to aquaculture but are facing challenges. What kind of subsidies or supports can be provided to them? I'd like to just take a quick moment to thank all the people from coastal India who have been giving me these sort of insights and sharing their experiences for all these years, and also to ASU, IPCC, National Science Foundation, and the Horowitz Foundation to help support this research. Part of this funding is also helping me make a short documentary film in the area that I'm working with Yashodhara Udupa, who's also from IIHS. So clearly it takes a village to do this kind of interdisciplinary work. I'm happy to stop now and take questions from you all. Thanks for listening.
Thanks, Garima. I see there are already a whole bunch of questions in the Q&A box, so maybe we should just get right to them. So I'm sure you can see them as well. And would you like to just take a look at them and perhaps club a few together and start responding?
Yeah, I'm looking at the first question, which is, do you cover only earlier storm surge affected areas, but there are also farmers in freshwater areas pumping saline water from a certain depth and then bringing into surface for shrimp culture? Yes, this results in previously freshwater agriculture becoming absolutely, yeah, that's so that is very clear, and especially in Andhra, that's a phenomena where people, farmers which are well inside, now the groundwater has become so saline, much interior regions as well, that they're able to pull just groundwater and practice the saline or brackish water aquaculture, even when they're not pulling water directly from the sea. So that's also leading to this exaggerated salinity intrusion all the way inside, like they're way up to about 50 kilometers away from the coast. Many of them, so these transitions are not limited to directly coastal areas, meaning they're not necessarily just directly taking water from the sea, or even backwaters which are saline, but they're also now taking water from bore wells. That's not happening as much in, let's say, Orissa and Tamil Nadu, where there are no subsidies for electricity for aquaculture, but it's happening in Andhra, where there's electricity subsidy, which is supporting this kind of transition or use of bore wells for taking groundwater for this. So the next question is, could you elaborate on what, according to your study, is defined as SES in your sites? Yes. So in my case, so for the condition of the feedback impact, I'm taking a village as my SES. I'm taking village conditions because here, because of cultural aspects and because of traditional sort of understanding of a neighborhood aspect, a village is usually where a lot of the social systems and economic systems kind of convene. Although environmental systems are, as we all know, are much larger for that. But for the purposes of this study, I'm taking a unit as a village. Happy to sort of, discuss this further if you're interested, Neeta. Muralidharan is also asking, land subsidence is not just influenced by seawater rise, but also excessive tap. Yes. In fact, that is the reason that they're finding in Vietnam, where they're pulling groundwater from for the purposes of aquaculture, but that pulling of groundwater is leading to land subsidence, and effectively they're calling that the effective sea level rise or variation. So yes, it's not. It's effectively this land subsidence is because of tapping of groundwater. You're right. There's a question on, you said that over irrigation in places like Punjab and Haryana can lead to high salinity and resulting in this kind of aquaculture inland. Can you explain how this happens? Intuitively, I would have thought that over irrigation would mean less salinity. Yes, that's right. But I mean, there are, and I can share different resources, even though that's not part of my direct research. But over irrigation tends to also draw out a lot of salinity from the soil, and so there are different sort of biophysical phenomena. Water does tend to leach away, and that is how one thinks of that. Water leaches away salinity, but because of sometimes lack of as water evaporates, also it also draws the soil's own salinity and also brings in other kinds of minerals and salts from other places and deposits them as well. So water is a very interesting physical thing that I found through my research, which I didn't know myself, and I'm finding more and more how complex it is. But yes, intuitively one may think that it is that over irrigation may cause less salinity, but actually it increases it. So you can read, there's one short film that Scroll has also made, and you can look into it, and I'm happy to share links of that where they have looked at this particular phenomena quite extensively. Okay, next question is from Venu Gopalan. Is the aquaculture land use shift in any way related to ruining of coastal commons? If yes, how does it impact living and working conditions of aqua workers in Andhra Pradesh? Very, very interesting. I think I've had this discussion briefly with you, Vinu, separately. But so it is. I wouldn't say it is ruining coastal commons. Yes, people are using coastal commons like mangrove areas, and also even public, so to say, gram panchayat lands, and they're collectively converting those lands for doing aquaculture. And it's potentially, yes, taking away those resources from people, and and those resources used to be commons in the sense that they were shared by multiple people and almost all people. Everybody, took advantage from that. But now, having converted these to aquaculture ponds, only few people have access to these lands. So there is so the fact that they are no more in some ways commons anymore, they're limited access to these lands now, and also impacts which were externalities, such as from mangroves, for instance, and with mangroves being converted to aquaculture, that may also have these implications. But I would say even broadly, one of the biggest common resources, groundwater, I mean, that is getting affected because of this. And, even if people are themselves not practicing aquaculture, but because their neighbors are practicing it and that's affecting their groundwater, that is the biggest sort of commons that is being affected by this. And that affects both living and working conditions for people in Andhra Pradesh, but also in Orissa and Tamil Nadu and everywhere. Can you share the slide on household trajectories? Can I take a screenshot for it for personal knowledge? Oh, of course. I mean, I'm happy to. I think this will be recorded and put on YouTube, so you're welcome to take anything that you feel like from this work.
Yeah. It will be on YouTube soon, so I would suggest just go to our YouTube channel and we'll share the link. And please feel free to with Garima's permission, use it.
Yeah, absolutely. And I'm happy to have a chat further if you're interested, Dalia. So Nina is asking, in your research, have you come across farmers who have started to consider low impact aquaculture, like multi-species aquaculture? It's very interesting. So I did meet some of the Krishi Vikas Kendra scientists, and they have been training some of the farmers to actually work on multi-species aquaculture, but also freshwater aquaculture. Some of the people who face challenges, let's say, with diseases with this particular shrimp variety or brackish water aquaculture, and especially because it was intensive aquaculture, they are seeking support now to think of alternatives because they can't continue practicing brackish water aquaculture because of high costs and big risks. So many of them are first either simply using they're using rainwater in the rainy seasons to cultivate some kind of rohu, katla, and other kinds of freshwater fish. But also, and these are low impact in the sense that they are low, they're not as intensive, so they're not growing, let's say, they're not putting 1 lakh seeds in 1 acre of land. They're probably like just putting 10,000 or 15,000 seeds in a 1 acre land, which is less intensive and possibly also less risky. It just takes longer for the produce to come out. Shrimp is just faster producing. In 3 months, they have the output, and that's why there's more, people are drawn to that a lot more. But slowly there is some shift, and there is some, some support that the state is beginning to provide through these Krishi Vikas Kendras on training for this. So yes, there is a little bit of that, not too much. I would say just at the top of my head, maybe 5% of these farmers who are even considering low impact aquaculture. Do your study look into the effect of proximity to shipping? So that's interesting. I mean, I have looked at larger sort of infrastructure systems in the sense that, shops for selling feed, and, for seeds and for labs, for testing, etc., and those kinds of things. Shipping, what's happening is that a lot of the produce is still going to Andhra Pradesh in the processing units, and they have many more processing units there. And a lot of the products are also coming from Andhra Pradesh, which makes things a lot cheaper for people in Andhra Pradesh per se, but not so much for states like Orissa, who are dependent on this system. So that's possibly, I mean, people have argued that, having or aquaculturalists per se, they have argued that having these resources of processing units and shipping and using the port, Paradip port, which is right there, but is not currently used for this, is primarily focused on, oil and other kinds of industrial uses, is not being used for fish produce. But if it does so, there's possibility that the prices will decrease and they may actually make more profits than otherwise. Nina is also asking, did you observe that in AP or in Orissa and TN? But I think the question is, is it related to a previous question, maybe? Nina's, I think,
Yeah.
previous question, I forget. What was it on?
On whether farmers have started to consider low impact aquaculture and multi-species aquaculture.
Yeah. So this was more, so low impact aquaculture, I think I saw more in Orissa, not so much in Andhra. I think what has happened is Andhra converted much before Orissa and TN, and by now, small farmers have already mostly been weeded out. So it's only large farmers there, and these large farmers are able to do intensive aquaculture much more. Whereas in Orissa, there's still, and even in Tamil Nadu, there's still small scale farmers, and they are continuing to do, and they're experimenting with, multi-species and mixing it up a little bit more than they are in AP. AP big farmers are even doing big fish, big saline fish, like, catfish, and they're growing other kinds of fish also in their ponds, but they are still intensive aquaculture. The last question, I think, is what your view on reshifting of coastal aquaculture ponds back to agricultural land. So, I have met villagers in Andhra Pradesh where, en masse in 1990, they converted to aquaculture. Then they faced these losses in early 2000s. And then en masse, they decided to convert back to agriculture. What they faced was that they had to obviously leave those lands fallow for about 5-6 years. Those 5-6 years, they had to move out for work and travel for or migrate for work, but those 6 years also required them to add, they had to bring in more soil, put that on top, add in more fertilizers, add in a lot more, put in a lot more inputs, which as a village, because they were a collective, they managed to sort of do it as a group, and they were able to sort of convert this. And now, even though their neighbors, the other villages around them are extensively practicing aquaculture, and many of them are, they're experiencing big, profits as well. But these villages, and this particular village that I'm talking about, having gone through this experience, they are committed to the idea that they will never convert back to aquaculture. That they may be producing less, they may be having less profits, but they are not going to convert back. The idea here, though, is that the reason why I call it irreversible is that it is irreversible in the resources available to these communities, in the time available to these communities, or important for these communities. 5-6 years leaving their lands fallow is not something that everybody can do. So shifting back from aquaculture to agriculture, while in theory is possible, in practice, some people have done it in big collectives, but for an individual farmer, and especially small scale farmers who are the dominant users of this, it is an irreversible land use change. So yeah, I think hopefully I have answered these questions, and I'm happy to continue these discussions offline if anybody is interested.
Yeah, we'll share Garima's contact information with anyone who'd like it. Please reach out to us. But just in closing, thank you very much for coming back. And we're looking forward to hearing what you find once you're done. So good luck, and we'll see you soon.
Thanks, Neha. Thanks a lot for having me over. Very happy to hear from everyone as well on this.
See you soon.
And we'll be in touch. See you soon. Thank you
very much for joining, and we'll see you at the next Publics.